Now we're going to actually graph these linear inequalities, and we will be graphing these on grids. So the first step in graphing these inequalities is graphing what's called the boundary line. When we graph inequalities on number lines, we put a dot at some sort of circle, either closed or open circle, at the critical value, and then deciding which way to shade. We're going to follow that same basic process, except instead of a circle, we're going to have a boundary line. So the first thing we're going to do is graph the line y equals x minus 2. So thinking back to what we know about lines, this is in slope-intercept form, where the y-intercept is -2 and the slope is +1. Now, the next thing we need to, so we've got the general direction of the line, the next thing we need to determine is what kind of line this is. When we graph these inequalities on number lines, we have an open circle and a closed circle, depending upon what kind of inequality we have. An open circle meant that that value was not included in the solution. A closed circle meant that it was. And we're going to kind of follow the same logic when graphing these lines. Now in this case, we have just greater than. It's not greater than or equal to, it's just greater than. So that means that that boundary line that we're going to graph, the y equals x minus 2, is not part of the solution. So the way we signify that when graphing these lines is we then graph a dashed line. It's not a solid line, it is a dashed line. And what that means is that the points on that line are not solutions to this inequality. For example, the point 0, -2, if we plug -2 in for y and 0 in for x, that would not make that inequality true. But something very, very, very close to this line does make it true. Now, just like with the number lines, we have to determine which side of this line to shade. And when we talked about the number lines, I talked about picking a point to test and then seeing which side of that line to shade. We're going to do the same thing here. We're going to pick a point to test to see which side of the line to shade. Now, the easiest point to pick whenever picking our test point is the point 0, 0. Okay? You need to pick a point that's not on the line, and as long as the line does not go through the point 0, 0, pick 0, 0. It's the easiest one to test. So, when we plug 0, 0, we're going to plug 0 in for both y and x. Is 0 greater than 0 minus 2? And the answer is yes. That is true. So, in this case, that means 0, 0 should be in our shaded region. So we're going to shade the side of the line that 0, 0 is in. So we're going to shade that side of the line. So your solutions to graphing these linear inequalities are a region. They're not a single line, it's an entire region. So any point in this shaded region makes this inequality true. For example, the point 1, 1 is in the shaded region. If we plug 1 in for y and 1 in for x, that would be true. Anything on the other side of the line makes it false. For example, if we pick the point 5, 1, for example, is 1 greater than 5 minus 2? Well, the answer is no, it's not. So any point in the shaded region makes that inequality true. Any point outside or on the other side of the shaded region makes the inequality false. So you're going to graph a line and shade one side of the line or the other. Now in part B, first thing we do is graph the line y equals 1/2 x plus 1. So to graph that line, again, it's in slope-intercept form, so the y-intercept is 1, and the slope is 1/2, so we're going to go up 1 and over 2. Now, in this case, again, we look at the inequality, which is less than or equal to, and since it's less than or equal to, that means the boundary line is included in the solution. Any point on this boundary line will make that inequality true. So, instead of a dashed line, in this case, we are going to graph a solid line. And a solid line indicates that any point on that line makes that inequality true. So, what that says is that that line is part of the solution. In this case, the line was not part of the solution, but a point very close to it was. In this case, every point on this line is a solution. Now we're going to determine which side of that line to shade. Since the line does not go through the point 0, 0, we're going to pick that point because it's easier to work with. So then, is 0 less than or equal to 1/2 times 0 plus 1? Well, 0 plus 1 is 1. 0 is less than or equal to 1, so that's true. So that means this point is in the shaded region. And any point in that region is a solution to that inequality. So for example, if we pick the point 0, -1, it will make that inequality true. If we choose a point 0, 2, it does not make that inequality true. So any point on this side of the line and on the line makes that inequality true. Any point on this side of the line makes it false. So you're shading 1/2 of the grid basically, one side of the line or the other. Now, both C and D, both of those inequalities are given in standard form. So we're going to graph 2x minus 3y is equal to 6 first. And the way you graph a linear equation in standard form is you find the x-intercept by covering up the y. So we take that y out. The equation we have left is 2x equals 6, so x is equal to 3. There is your x-intercept. And now, to find the y-intercept, we do the same thing. We remove the x term. So we have negative 3y equals 6, so y is negative 2. Now again, to determine what kind of line we have, we look at the inequality symbol. It is just greater than. So that means the line itself is not a solution, so we're going to graph a dashed line. That tells us once again that any point on that line does not make that inequality true. It is not a solution. So, once again, this line does not go through the point 0, 0, so we're going to choose that to plug in. 2 times 0 is 0. 3 times 0 is 0. Now, 0 minus 0 is not greater than 6. So then, this point is not in the shaded region. So we're going to shade the opposite side of the line. So we're going to shade down here. like the point 0, -3. If we plug 0, -3 into that, it would make that inequality true. Anything on this side of the line makes this inequality false. And finally, D, another equation in standard, an inequality in standard form. So we're going to graph the line x plus 5y is equal to -10 first. Taking out the y, we have x equals -10. Taking out the x, we have 5y equals -10, so y is -2. So then in this case, the kind of line that we have, since it's greater than or equal to, we're going to have a solid line. That means any point on that line satisfies that inequality, so it makes it true. So then we need to determine which side of that line to shade. Again, this line does not go through the origin, so we're going to choose that. Is 0 plus 0 greater than or equal to -10? The answer is yes. That is true, which means the point 0, 0 is in that shaded region. So any point in this shaded region makes this inequality true. Any point outside that shaded region makes it false. So that is graphing linear inequalities. Well, we're going to take a look at a couple of special cases where we only have one variable, x or y, so we have to refresh our memories on what kind of lines these are. And again, you do it the same way. First, you want to graph that boundary line, x equals -1. Now, since we only have one variable, that means that that line only crosses that x-axis. Okay, looking back here, we had both x and y in our equations. The lines cross both axes. In this case, we only have x. So that means that the line only crosses the x-axis. And it crosses the x-axis at -1, so we have a vertical line. It will never cross the y-axis since we have no y in the equation. Now, what kind of line should this be besides vertical, since it's only greater than? The line itself is not part of the solution, so this is going to be a dashed line. Because if x was equal to -1, that does not make that inequality true, so it is not a solution. Now, since this line does not go through the origin, we can test the point 0, 0. We're going to plug the x-coordinate in for x. Is 0 greater than -1? The answer is yes. So therefore, the origin is in the shaded region. So we shade that side of the line. Any point on this side of the line makes that inequality true. Any point on this side of the line does not make it true. Now, in the second part, first thing we're going to do is graph the line y equals 2. Once again, we only have one variable in the equation, which means that that line only crosses the y-axis, and it will cross the y-axis at 2. It will never cross the x-axis because we're missing the x. So in this case, since it's less than or equal to, that line is part of the solution, so it is going to be a solid line. It crosses the y-axis at 2. Since it does not go through the origin. We can pick the origin to test. Y coordinate there is 0. Is 0 less than or equal to 2? The answer is yes. So then that is the side of the line we shade. If 0, 0 made that false, we would shade the other side. So every point on this side of the line makes that inequality true. Every point on this side makes the inequality false. So therefore, they are not solutions. In the next video, we're going to go backwards. We're going to take a look at a graph and come up with the linear inequality that that graph describes.